Come back. So we'll talk about chapter number 8 today. Chapter number 8 is the first chapter where we talk about structured data type. In the first 7 chapters, all the data we referred as a simple data type. We talked about integers and strings and characters and booleans. All those, when you deal with all those kind of type of data, those are simple data types. So this is the first chapter. We talk about arrays. Arrays are basically collection of different pieces of data. And how do we deal with that data? Because in the real life, you don't have individual data. You don't have only one customer. You can have thousands, if not millions of customers. And how do you deal with their first names and last names and email addresses and all sorts of data? So arrays is one of those techniques where we can deal with the large amount of data of same type, and we can store it, we can search it, we can sort it. It's easier to process it. So this is the first chapter where we talk about structured data types. There are many, many other structured data types. Some of them you learn in introductory class, and some of them you learn in advanced courses, and some of them even in data structure courses. So those are kind of concepts which are a little bit more advanced. So even this chapter, it might feel that it is hard to grasp because this is the first time we are making a switch from simple data type to advanced or structured data type. So we'll talk about what are arrays, how do we sequentially search them, how do we process the contents of an array, what is the concept of parallel array, and we'll talk about two-dimensional, maybe three-dimensional arrays, and so we'll go from there. All right. So array is allows you to store the group of items, let's say all first names, let's say all cities for each customer of the same type. So that's the key here, guys, the same data type. So all first names are string data type. For example, all the balances or their any real data of that type. So we store them contiguously in the memory right after each other. So if I have a lot of first names, a lot of last names, a lot of customer information, I can store all the first names in one array, all the last names in another array, and on and on. So those are called contiguous in nature, and they are the same type. That's the key here, same type. And also another limitation or requirement with array is you must know the size of the array. And in a simple array, we need to know the size of the array. Later on, way later on in an advanced course, you'll learn something called dynamic array, where we also call them in some languages vectors, where you can increase the size during runtime while you're executing the program. But we are not going to talk about it in this chapter. So here we are just going to learn that the data must be of same type. Data must be exactly the size we declare at the time of the creation of the array. All right, so why do I need to do this? Because instead of multiple simple variables such as employee one, employee two, employee million, 500 million, so that will be very cumbersome to handle. So instead of doing that, we can actually have an efficient way to do it, efficient way to deal with. We can have one variable, and that variable can be declared as, let's say, string. So that's a data type, and we can call it employee, let's say employee first name or employee last name. And then we can provide the size here. This is what I was referring here. You must know the size of how many employees at the time of the creation of an array. And in this particular case, only 50 employees can be created, or 50 first names can be created. You cannot have 51. So and all the employee first names, assuming this is a first name, employee is not a good variable here. The variable here, it should be employee first name, or it should be first name. So it should be of string type. So if I have another piece of information for this employee, I cannot store in this array because this must be of string type, and this must be of size 50. All right. So, but how about employee also have some sales amount? So this is the sales amount for the same employee. And notice that their sales amount, they are size 7. All right. So this is our double data type or real data type. So notice that there's something else we are introducing here, these two square brackets. The square brackets in most of the languages, almost all the languages, they indicate it's an array. It's not a simple variable anymore. So whenever you use square brackets right here and right here, it means it's an array. It's a structured data type, which means expect to find additional elements. So each one of those pieces of information where it is stored is called an element. We'll see in the next screen just in a few seconds. All right, so just remember that once, whenever you see square brackets, not parentheses, not curly braces, square brackets, it's basically tells me it's an array. All right, so the storage location array are elements. So these are each element, one element, two elements, second, third element, fourth element, fifth element. So just remember that if the size is five, there are five elements. So each one of these. And then how do I go from one element to another element? That's where a concept comes called a subscript. Subscript is also called index. I'll come back to that concept just in a second. Let's read the definition here. Each element of the array has a unique number called a subscript or an index that identifies it. So subscript starts at with zero in most of the languages. All the languages I work with, the starting index or starting subscript is always zero. Take a look over here. The first element subscript is zero. The second element subscript is one. Third and fourth. Notice that the fifth element has a subscript of 4 or index is 4, which means the index 5 or subscript 5 is not accessible. It is out of boundary. It is out of bound. I cannot access this part, this neighborhood. I cannot access this neighborhood before subscript 0. Okay, so my access in the RAM, this is in the RAM, this is random access memory. This is how it is created. This is how my compiler, with the help of the operating system, accesses this part of the memory. So this area is not accessible, which is subscript 5, or this subscript -1 cannot be accessed. So when you declare size 5, and then this is how it is dealt with in the background. So these are different numbers. So here's a number, integer, size is 5. So first number will be stored here, second here, third, fourth, and fifth. All right. Now this is kind of not how we grew up learning math, because in math, typically when we start something, we start with 1. So 0 means you have nothing. 1 means you have some kind of object in your possession, which is 1. When you add another one, you have 2. Let's say $1, $2. You don't say I have $0, which means you have $1 in your possession. That's not how we are trained. Our brains are not trained. So chances of making a mistake is very high when you deal with these programming languages. So be careful, just somehow you need to remember it. At the time of the creation of these concepts, the developers of these languages, this is how they did it. There must be some reason. I don't know the reason behind it. Some person just decided to do that at some time period, and everybody else just followed blindly, unfortunately. So here it is. If the first number is stored in subscript 0 and value is 20. And the last number, the number of 5 is stored in subscript 4, the value is 60. So assigning can value using the, you can assign values, or you can modify the values, or you can actually display the values by specifically providing the subscript or index in the square brackets. But it would be better. Imagine these are only 5. What if we have 5 million? We can't really access efficiently like that. So it's better to use some kind of loop, which we'll see that in just a couple of slides. So here, assume we have 3 elements, first, second, third. So first element is always subscript 0, then 1, then 2. So we can store the contents of hours. We can simply say hours square bracket 0 equal 40. We can store it that way, or we can read the data from the user, or from a database, or from other sources as well. So you can also, we're still learning how to declare and initialize them. You can also, what if you you have the initial values in hand? So you can actually do this way as well. Typically, in most of languages, there's a curly brace here and curly brace here, especially in C++ and some languages, this is how they declare them. But anyway, I'm going to leave that one for right now because it's just a pseudocode. It's just showing you how you can actually have 7 days. We know 7 days, and we know the first day is always index 0 or subscript 0. So that will be stored in the first index or element 1, the second index, third index, fourth index, fifth index, sixth index, and this is the seventh index. Now, seventh index has a subscript of 6 because started with 0. This is 0, so this will be 6. So if you try to do this, for example, this will be an error message because the maximum possible is 6, not 7. So that's why the book is indicating here. If you try to do this, it's going to be invalid because 7 is out of bound. It's not part of your boundary. So array bound checking should be performed to avoid any invalid subscript. You have to be very careful when you are dealing with these. So a common error is running a loop one time more than it's necessary, exceeding the boundary of the array. And you might see an error message, array out of bound, or some kind of error message indicating that you did something illegal. All right. So partially filled array, sometimes an array is only partially filled. Let's say you create an array of size 1,000, but you only have 3 customers. So what do you do with the rest? So avoid processing the unfilled elements. You must have an occupying integer value that holds the number of items stored in the array. So it's talking about logic here. So you have created an array size 1,000 or 1,000,000, expecting that many items or customers will be added, but you only added 3. So it's indicating here you must have some kind of counter variable right here, counter variable, which counts how many elements or how many customers are added. So in that way, you don't have to cycle through unnecessarily. The iteration is going to be useless if you go a million times, but you only have process to 3 customers. So when array is empty, the counter should be 0 in that variable. That's what it's indicating here. When the variable is incremented, let's say the counter is incremented to 1 or 2 or 3, then it knows how many elements have been added in the array. So variable's value, the counter variable value, is used as array size when stepping through the array. All right, so it's a logical thing to do. So you invited, let's say, 1,000 customers to a party, and only 10 people confirmed it. You don't have to order food for 1,000 people. You just need to order for 10 people because you are counting how many confirmations are there. That's exactly what it's indicating here. All right, so this one here, size is 100 and integer values 100. So you created in this line of code right there, it's indicating create values variable, array variable with size 100. So 100 of these spaces or elements will be created in the RAM. And this is my count variable to count how many are populated. And a couple of other variables, we'll see what the purpose is. So here we are asking the user, please hit -1 or enter -1 to exit. Otherwise, keep giving me a number. So if the number is not -1 and the count is less than size, count is basically 100. If you remember, we just created that size is 100. So we're going to cycle through this one. We're going to say, okay, whatever number you have given me over here on the top above the while loop, I'm going to add it to assign to value count. Count is 0 initially. Then count becomes 1. Then give me the second value. Let's say the user gives you second value 50. So because it is still within the range, it is not -1 and the size is still only 1. So then it is also added into that one and to the next. So this is how it's assigning each number to an array element. It is producing an array basically. At one stage, the count will become 100, exactly 100. We will exit the loop because there's an and operator here. Or if somebody enters -1, after 3 or 4 values, they say, I had enough. I want to exit this loop. So in that case, it will exit. So here, the values you entered will be displayed in this for loop. And this might be partially filled array because after 3 or 4 elements, when you exit, you still have additional elements, but you don't have to display additional elements because that's not the goal. Goal is to display only the content which was populated. So in some languages, they have a special for loop. We'll see next couple of slides, which allow you to cycle through on that. Even in other languages, the traditional for loop, we have the absolute control, but they just created another for loop. So it's going to only show you how many variables what the value of the count was assigned at the time. Because every time we incremented the count, let's say the count became 3. So first value was 0, 1, 2, and 3. So that's why we're doing size -1, because array, when you display the content or access the content, it is always the size -1, always size -1, because it begins with 0. All right. So let's move on. So there's a for each loop. Some languages have them. It's an optional topic. Many languages provide for each loop. It works with an array, iterating once for each array element. During each iteration, the loop copies an element. Many languages do not have it. Some languages do. For each variable in array, display or process these statements. Here, array basics size is 5. So here's 5. We add 5 here, basically. And then we can also, in many languages, this is how they do it. But here, it's not shown like that. But that's OK. Just want to show you that we are not writing the language, really. We are just looking at the pseudocode. So these are the 5 elements added to that array. And then you can actually cycle through it because each one of these, this is your array. That's your array right there. And you go through the number sequence and it displays the number in that way. So then you can do different types of searches and sorting. I think this chapter only talks about search and doesn't talk about sort. Remember, there are many organizations, very large organizations. They're worth almost 3 trillion, 2.5 to $3 trillion, their market value. And the only job they do is search and sort. In fact, I'm referring to not only Google, but many, many, many companies. That's the only job they do. They basically search the data. They have special techniques to search more efficiently. And there are many other techniques also other companies also do very similar things. So one of the search, and this is not the search they use, of course, their searches are way more complex. This is the easiest search in a sense that sequentially it goes through first element to the second element to the third element. It goes through in the sequence. And when it reaches the last element, it exits the loop. So sequential search is also called linear search. It's the easiest search. It's an algorithm. It's a simple technique of finding an item by going through sequential manner. It finds, let's say, item number 3 matches the criteria. Now you have the option. You have the option to exit at that time. You don't have to continue to search. Or if you want to continue to search to find additional matches of the same type, assuming there are duplicate values, you can continue. But if there are no duplicate values, then you can exit at that time. So typically, to do that kind of search, sequential search, you need a loop, of course, to sequentially step through an array. So you cycle through, you iterate through the entire array, you're looking for that value. You compare each value, each element with a value being searched for. So let's say you're searching for city of Long Beach. So you match with the first element. Do you have Long Beach? It says no. You go to the second one. Do you have Long Beach? No. You have third one matches. And at that time, you can exit. So you compare each element. And again, like I stated, after the match, if the values are not duplicated, it is a wise thing to do to exit the search at that time because you found that value in element number 3 or index 2. And that's what he's saying in the next one. Stops when the value is found or the end of array is hit. Depending upon what type of data you're searching, it is possible you might have duplicate values. You want to continue to search the entire array. And this is the logic shown over here. So you have the index 0 because we always begin with 0. And assuming nothing is found, that's why this Boolean found is created here and set is to false. And here it says found equals false. Yes, initially nothing is found. And index is less than size minus 1. So let's say the size is 1000. So it's always 999 because the starting index was 0. So 0 through 999 makes it 1000. So size minus 1. And then you are searching the first index. Remember the index is 0 right there, array index 0 equals, this is what you're searching. The search value is what you're searching for. Let's say like I stated, you're searching for Long Beach. And if we equals, make found true. If not, make the index 1 and continue in this loop. Stay in this loop. And if it's found, then you can exit at that time. And of course, this particular logic is very simple, just to show you how the logic runs. But there could be additional statements. Maybe you want to display that one. Maybe you want to capture where the index was. Maybe you want to do a variety of things. Maybe you want to modify that value, whatever the goal is. But here is just showing you how easy it is to do the linear search or sequential search. And literally, we have 5, 6 lines of code. And you can say, well, this is so easy. I'm going to start my own Google and I'll be making so much money. Of course, their search is not sequential search. In fact, they were in Stanford University, both of their partners, and they had an idea of making search and sort. Remember, sorting goes hand in hand with search. And they went to their professor in Stanford, and the professor said, well, this is a brilliant idea. All I have is 100,000 of my retirement savings, but I'm going to invest in your company. Guess what? That professor made $8 billion after later on. He's worth $8 billion. So some of these ideas come and by the way, they dropped out from Stanford and they started a company called Google. This is not a very long time ago. This is only 25 or less than 30 years ago. And look at the size of the company and how they grew. Uh, all right, so totaling the to the values in array and calculating average. So once you know how to grab each value, it is very easy to do the totals. We did that in previous chapters where we did sum equals to value plus sum or sum plus value. We did something very similar. Once you know how many values are there, you can divide by the number of values and you can also calculate average. If there are only 3 values, so you can dump everything into the total and then total divided by 3, for example. So here loops are used to accumulate the values to get the total. Then the total is divided by total number of elements, which is in this case is size. So it's very, very easy to grab those values. This would be a 1 line of code right here. And then this will be another line of code. There's only 2 lines of code and you can grab the totals and averages. I think it shows you over here. And here it gets the total right there. Total equals to total plus each value. Remember, we are dealing with numbers here. So index is 0, index is 1, index is 2, index is 3. And every time you read that value, dump into total, and then right here, total divided by size, and display them, both of those values. You can display the total as well as averages. Finding the highest and lowest values in an array. The highest value, create a variable to hold the highest value, assuming the first value is the highest value. Assuming, because imagine the highest value is somewhere in the middle of the array, but you do not know that. So you can take the first value, put it in a variable, and assume that's the highest value. Then compare with the next value. If the next value is the higher than the first value, then assign that to the variable and do the same thing until you find the highest value. So that's what it's highlighting here. Create a variable to hold the highest value. Okay, you need a variable. Assign the value at the first element as the highest value. That's why I stated earlier. Logically, this is really, really, really easy. Then use a loop to step through all the elements. All right, so we did 3 things. We created a variable. We assumed the first element Element 0 is the first element. The value in the first element is the highest. We assign to that variable. And then we have a loop to cycle through the entire array. Then during each iteration, each cycle, a comparison is made to the highest variable, which is the variable we created here. And then we compare, do you have the higher value than the variable value I have? If it does, then you store that next higher value in that same variable. If the element is greater, that's what I just stated, in the highest value, then value is then assigned to the highest variable. How easy it is to find the highest value. And the same process can be done for the lowest value as well. Okay, copying an array can be done using loops. So you have some kind of array, let's call first array. First array could be 1,000 different elements. You want to copy all of them into another array. And this is how you can do it. Just one line of code. And because index is always begins with 0, so zeroth location, copy everything, go to the first location, second location, and you can just in one line of code, you can copy all the element values from one array to another array. Passing an array as an argument in many languages, you must pass the array and the size of array as an argument. Now, this actually varies a little bit in some languages, and we'll see how we pass an array. But make sure whenever you are passing array as an argument, it has the square brackets in the parameter list or argument list. The square bracket indicates array is not a simple variable, it's an array variable. And this is just the name of the function. This is just the header of the function, or we also call a signature of the function. And also it's a good idea to pass the size, because this get total function doesn't know anything about it. So we are not only passing the array, we are also passing this array size. So this function knows how to deal with this particular. So that's what it's highlighting here. So passing array is an argument. In many languages, you must pass the array and the size of the, like we indicated earlier. So you pass the array a variable name as an argument, as well as the size of the array. By using the same subscript, you can establish a relationship between data stored in two or more arrays. So this concept is called parallel arrays. Now, parallel arrays, now if you remember the first couple of slides we saw, and I had indicated that an array has some limitation. One of the limitation is the exact same amount of data must be stored in that array. For example, if this is a names array, all elements should be names. Name 1, name 2, name 3, on and on. Johnny, Mary, whatever it is. You cannot say, okay, I'm going to store Johnny here and I'm going to store some kind of numeric data here. You cannot do that. However, what if I have Johnny has some address, Johnny has some email, Johnny has some zip code, Johnny has some kind of additional information, balance, for example. Then what you do, you create different arrays, one for the names, one for balances, one for the city, one for the zip code, one for the other things. And then you connect them logically, not you do not somehow combine them into array, but you create multiple arrays, and you use the indices or index or subscripts to create that relationship between them. So that's what it's highlighting here. By using the subscript, we can establish a relationship between data stored in two or more arrays. So I know element number one, or in this case, a subscript 0, it belongs to Johnny. For all the arrays, let's say there are 10 or 20 or 30 different arrays. Whenever we deal with 0th index, 0th subscript, or we are referring to element 1, all the data stored in this array, another array, will be all about Johnny. So this kind of concept is called parallel array. And remember, I'm just saying this is your logic. This is not somehow you're forcing the language to make that connection. You are developing the logic in order to establish that kind of relationship. Okay. Now let's move on a couple of slides, and then we'll talk about two-dimensional array. Most of the time, you might not be using two-dimensional array that frequently. There are other techniques as well, but two-dimensional array is when you have concept like rows and columns. And you see such a concept in spreadsheets, for example. You have row 0 all the way to row number 5, then column 0 all the way to column number 4. So you have rows and column. The intersection between row and column, that is called a cell in a spreadsheet. So the two-dimensional array is the same concept. A two-dimensional array is like a several identical arrays put together. So suppose a teacher has 6 students who take 5 tests. So 6 students are indicated in rows, and their test scores are indicated in columns. So if I want to look at the second student is in row number 2, and look at their third test score, I will go over here, right, right here. This is the second student and test score number 3. Because the starting index is 0, that's why it's number 3 here. Because this row number 0 is the starting index, so that's why this is the second student. So this is how you can actually, again, this is all logical, guys, by the way. So it has nothing to do with some kind of special programs you have to deal with. It's just a logic, and it's going to show you a couple of examples here. So you have, let's say, 3 rows and 4 columns. And how do I declare it? Instead of just one of these square brackets, you use 2 square brackets. The first one deals with the rows. The second one deals with the columns. So now you're declaring two-dimensional array. So, and of course, when you have two-dimensional array, you need 2 for loops. You need a for loop for the rows, and you need for loops for the columns. And then 0th row, 0th column. 0th row, column 1. 0th row, column 2. 0th row, column 3. Once the rows have been exhausted, row 1, column 0. Row 1, column 2. Sorry, column 1. Row 1, column 2. Row 1, column 3, and so on and so forth. So that's how you can iterate and cycle through two-dimensional array. Now, if you can deal with that one, you can, of course, add three-dimensional array and many, many other dimensions as well. Now, again, this is a little bit advanced concept. Generally speaking, we only discuss this one probably at the end of our classes, and that's what we are talking about it in chapter number 8. But before you get to this chapter, you have gone through so many different types of concepts, so this will not probably feel very difficult for you. All right, so here is can be 3 or 4 dimensions, and if I want to declare three-dimensional array, let's say different seeds, this is my first the first 3 here, first dimension, second dimension, third dimension. So in the first dimension, I have size 3, then size 5, then size 8. If I want to know how many maximum elements I can store, let me go back here for a second. If I want to know how many maximum elements I can store in this values array, all I have to do is multiply 3 times 4. 3 times 4 is 12. 12 maximum values can be stored here. In this case, if I want to multiply all 3 of them, 8 times 5 is 40, 40 times 3 is, 3 is 120. So 120 different seeds can be assigned in this three-dimensional array. All right. You probably will not be creating three-dimensional array in our class or many other classes, but it's just a concept you have to know. All right, how do we implement this in different languages? Let's go through the languages. And so here in Java, so you want to create an integer, whole numbers. This is the variable name, and you indicate that this is an array by using the square brackets. And new keyword is used, so you can assign, and you can assign 6 elements at the time of the creation of this array. So the statement declare a number as an int array. Int array, number is an int array. How do I know it's an array? By looking at the square brackets right there. The size declarator specify the array size is 6. So here is array size is 6. By the way, there are many different ways you can do it, but this is just one way it's showing you. It is a good practice to use a named constant for the size declarator. So basically saying it's subtracted practice. You can actually assign 6 in size variable, and then you can use the size it will be a better practice. All right. So the following code declares temperatures as an array of 200 doubles. So again, size is 200, temperatures, double data type. It's an array by looking at the square brackets, and I can see the size is 200. So the following code declares an array of 10 strings. Okay, same idea. Size is 10, size is 10, strings, and names are strings. So it's showing you how to declare whole numbers, integers, how to declare double data type, and whole number. I just want to pay attention. I want you to pay attention to something here. Notice that the size is shown as constant. In Java, it is shows as final is a constant, which means I cannot change the size of my variable, the size of my variable size to 7 or 8 or 10 later on. When I declare as size 6, it is fixed, cannot be modified because arrays are very careful. Remember in the second slide we saw, the third slide we saw, the array size must be given, must be fixed. These are fixed sizes. So if I have the array number size 6, I cannot change it to 7 or 10 or 12 later on. These are fixed number of components, fixed number of elements at the time of the creation of the array. Same thing you notice here. Whenever we deal with size, it is always has final size. It always has constant or final. In C++, you will see something is called constant, not final. Here, same thing over here. Size is final, size is 3, and the numbers are created. And this is where it's assigning different values to the first element 10, the second element 20, the third element 30. Because the first element subscript is always 0, the last element is always size minus 1. Remember, size was 3, so size minus 1, 3 minus 1 is 2. That's the maximum size possible. We cannot store something in numbers 3. That is not possible because that is array out of bound. You can also initialize arrays this way. And if you remember when I was showing the pseudocode, I was putting the curly braces before and at the end and with a semicolon. And the semicolon is required in many languages, not in Python, but in Java and C++, C Sharp, and C language, you will see the semicolon. Semicolon is just like in English language, you have period at the end of the sentence. If you don't have a period, I do not know the next statement is part of the sentence or it is not part of the sentence. So semicolon in these languages is required. I must have mentioned in the beginning. If not, just remember that here we are indicating this is the end of the statement. So I did not declare the size here, but I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So size of number of days is 12. And the first value, 31, is stored in the 0th index, which is this one here. The second value, 28, which is right here, is stored in days 1, and so on and so forth. Okay, and let's look at a couple of more examples. The length attribute holds the number of elements in an array. We saw that one earlier as well. So here we know the size is 25 for temperatures. Because the temperature array has 25 elements, the following statement would assign 25 to variable size. So here, you can actually get the length. You can get the temperature.length. It's a given function to us, so that you can store in this size variable. And then you can cycle through this for loop. You can see int I equals to 0, and you can cycle through by the size. By the way, you can also say size here because you already assigned that one to size. So here you can simply type size as well. And I++, and it cycles through and displays all the values. When passing an array as an argument to a method in Java, it is not necessary to pass a separate argument indicating the array size. That is true. It is optional thing to do. It is a recommended thing to do, although it is not required. That if I'm passing this particular array, this array is of this type, integer type, and I know I'm telling this show array function that it's an array, then what it's indicating here, your author is telling you the size is not required. However, there are a lot of things are not required, like getting an education is not required in a society. Like finishing college is not required, but it is something recommended. Absolutely. It is highly recommended you always pass the size to another function because that function doesn't know. And you can argue, well, if it doesn't know, I can use array.length. I can use something like that. I agree with that one. But in many cases, if you are dealing with some kind of other kind of complex issues, it's not a bad idea. But then you can cycle through this one as well. Two-dimensional array in Java, you will be using two square brackets at the time of the declaration of that variable, array variable, and then you are providing the row 3 times 4. So this is how the first data will be stored. This is row 0, column 1, sorry, column 0, which is basically the first row and first column. Row 0 and column 1, which is the first row and the second column, and on and on. And that's how you can access all the elements in an array. So the last thing, again, you will probably will never use three-dimensional array, at least not in this class, or maybe not in any introductory class, maybe somewhere. But if you just want to know how to declare it, this is how you declare in Java. You will be using 3 sets of brackets because compiler needs to know what kind of what is seats. Seats are basically double data type of three-dimensional array. And then this is the size of each one of these. So 3 rows, 3 columns, and then what is this 8? So this 8 could be another sheet. Remember in Excel, for example, if you have a spreadsheet, so you have rows and columns, the third dimension could be another sheet, sheet 1, sheet 2, sheet 3. What if you add the fourth dimension? That could be workbook 1, workbook 2, workbook 3. What if you add another dimension? That could be the application 1, application 2, and on and on and on. So conceptually, you can actually figure that out how that is aligned. And this array can be thought of as 3 sets of 5 rows, which each row containing 8 elements. All right. Let's look at the same concepts in Python. In Python, even numbers, if you remember, we don't need to provide the type of data type. In Python, it automatically figures that out. It knows these are whole numbers. Or it looking at the data, it says, okay, I'm storing 2, 4, 6, 8, and 10. And it automatically knows there are 5 elements. So because it's a fairly new language, so it's they have removed some of the other restrictions from the previous one. So here, this statement declares even numbers as list. The items inside the brackets are the elements of the list. And here you say names. Names are basically strings. The first element, the second element, the third element value, fourth element value, fifth element value. And here you can access the elements the list with the subscript. Subscript start at 0. So here you can see the 0th subscript. That doesn't change. It's the same thing what we saw in Java and pseudocode. The first element will be assigned. The second element will be assigned 20. The third element will be assigned 30, and so on and so forth. Initially, this is the initialization part of it. At the time of the creation of a numbers array, we did not know what values will be added. We just basically initialize everything to 0. The length function returns the number of elements in a list. So here we have size 3, as you can see. So you can actually say, okay, I want to find the length function returns how many elements are there, and I want to store in size. So you can do that as well. So it's very useful. We saw the similar thing in Java where it used the full word length. So in this case, it's len. It basically tells me what is the size. So that actually makes it easier when you special cycle through your loop. So you say index less than length of that array. So let's say there are 4 elements. We have 4 elements, 1, 2, 3, 4 elements. So 4 elements, and there are 4 pieces of data assigned to my list. So I want to know the length. So length will be 4 here. This will be 4. So index is 0. Is 0 less than 4? Yes. Make it 1. Is 1 less than 4? Yes. Is 2 less than 4? Yes. Is 3 less than 4? Yes. Then at one stage, index becomes 4. Is 4 less than 4? No. Then it will exit the loop. How easy it is to manage it. In Python, you can easily iterate over the elements of list with a for loop. Um, and we saw that in pseudocode in multiple places. And your numbers, that's your array. And you have n. N is the first element value will be picked up and display the n. So variable n is assigned to copy of the first value in the list. Then the statements that appear in the block are executed. Then the variable in n is assigned the copy of the next value, and so on and so forth. This continues until all the values have been picked up successfully. When, when passing a list as an argument to function in Python, it is not necessary to pass a separate argument indicating the list size. And that's what the same thing we saw in Java as well. Inside the function, you can use the length len function, just like with what we saw in Java as well. And here's your function name, set to 0. That's a function name. That's your array. And notice that in Java, we had to pass the square brackets to indicate to that particular language, to that function. That's an array. In Python, it's really not necessary. It will figure it out. This will tell me the size of my array, and then I can easily cycle through it. Two-dimensional is very similar. The only thing slightly different here is the following statement decrees a two-dimensional list with two rows and columns. This is the first area where we are creating the first dimension, and this is your second dimension here. So each dimension has 3 pieces of data. Then you can cycle through it by 0, 0, just like what we saw earlier, 0, 1. So this is your first piece of data. First piece of data is basically 1 here, and so on and so forth. Use nested loops to iterate over a two-dimensional array. Typically, it's recommended, although there are some techniques not to use two loops, but it is much, much easier to understand in two loops. So here's you have some data set, and you can see some data set here, and you have 3 rows and 3 columns. So you can see row 1, and each one has some columns, 3 columns. And then you say row is less than row. So first, because row comes first, so you will cycle through the 0th row, and then you will cycle through assuming the column is 0 initially and row is 0 initially, and 0 is less than number of columns at 3 column altogether. And then you will display 0th row, 0 column, 0th row, first column, 0th row, second column. So first cycle has been completed. Then you also increment row to 1. Then you go back here. 1 is less than the number of rows, which is 3. And you reinitialize 0 to column. So you can cycle through the next data set as well. Okay. We are almost at the end. Now, what do we do in C++? So in C++, this is how you declare an array of size 6. And also it's indicating it's a good practice. We saw the same thing in Java to assign this 6 into size, but it must be a constant. If it's not a constant, it's going to be a syntax error. It's just like in Java, we did final. Here we say constant. And the type of data we are going to store is integer. This is the name of the array. This is the size of the array. And size is assigned, 6 is assigned to a size variable. So this is what it looks like. Although this is not required, but it's recommended highly. It will make your coding much easier, especially when you go through the cycles and so on and so forth. So following code declares temperatures as an array of 200 double data type. So here temperatures are declared as double, size is 200. And the code declare the strings, names are strings, and size is 10. We saw something similar in Java and Python as well. So you can access the elements in array. You can assign the values. So you can input the values. You can read from a database. You can read from a file. Here we are assigning 10 to the first element, 20 to the second, and 30 to the third one. We saw very similar things in the previous languages as well. So how do we initialize an array? So let's say size is 12. So there are 12 elements in days here. So if you know the initial value, which is probably not really possible most of the time, you do not know the initial values. The values will be given by the user. or read from a file or a database or some kind of sensor or some kind of other device. But assuming if you already know the values, you can assign them in curly braces and end with a semicolon. That's one way, but most probably you will not doing such a thing. The first value 31 is stored in day 0 right there. The second value 28 is stored in day 1 right there. We saw something similar. When initializing an array, it is not necessary to specify the size declarator. So here it's saying you don't need to say size 12 here, because it's going to count. The compiler is pretty smart. It's going to count 1, 2, 3, 4, all the way. It's going to automatically assign the size in that case. I agree with that one, but it's not a bad practice to do this way as well. There's nothing wrong with that. Okay. So how do we passing array to an argument function in C++? You should also pass a separate array size right there. We are passing the size and we are passing that array. And also in Python, the square brackets were not needed. When you're passing an argument in Java and C++, they are needed. There's no built-in function for array length in C++. So remember in Java, there was a length function, and in Python, there was a len function. So here, there's no such thing. That's why it's a good practice to pass the size so we can iterate through the entire array. How do I declare two-dimensional array? There it is. Two-dimensional array of double data type, 3 rows and 4 columns. And we saw something similar a couple of times earlier, so I'm not going to spend time on that one. And again, it's a good practice to use for loops. One for the row, as you can see, and the second for loop, the second one is for the columns. So you can actually access the data from a user. You can ask the user and populate those arrays. So first row 0 will be populated with column 0, 1, and 2, and 3. Then row 1 is column number 0, 1, 2, and 3. Column 2, sorry, row 2, column 0, 1, 2, and 3. So that's how 3 times 4, 12 values will be populated in that particular array. How do I declare a three-dimensional array? You can see very similar to what we saw earlier. And you will hardly use this in my class or other classes, but just in case if you go to an advanced course later on, you want to declare three-dimensional array. This is very similar to what we saw in Java as well. All right, we finished our chapter, and this is the first chapter. We talked about some of the advanced concepts. The structured data type. Previously, what we were dealing with was a simple data type. Hopefully, this will help you to understand how the structured data types behave and function. And then finally, we'll move on to chapter number 9 next week. All right, thank you very much. Bye-bye.